So, so yesterday last problem was done. Everyone could solve it, and the values I have shown in the last slide, and along with which is compressive and tensile. So I hope it is fine. Then we'll quickly go for the next problem. That is, these are straight lines, okay? Just here and right. So you have to find out the forces in all the members. Yeah. Yeah. I will ask the answer after some minutes. Please do it.
Sir, where is G, sir?
Hmm?
Sir, you
Where is?
didn't name the G.
Okay, 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 okay.
You forgot to name
Yes,
that.
yes, 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 yes. Sorry. Yeah, thank you.
अभी कुछ नहीं.
Which should be our first step?
To find RA and RB.
What are the values?
Sir, RA is 11 kilo on Newton and sorry, it's RB. RB is 11th.
Okay, and RA?
RA is 10.
Everyone got that? If it is fine, then please go ahead for the other members. Quickly, it is easy. You have to do some complicated problem as well. What is FAC?
The findings, sir.
Yes, if RA is at point A is 10 kilonewton, what will be FAC?
Sir, 10 kilonewton in the opposite direction of RA.
Opposite direction मतलब compressive और tensile हो बोलो.
It's compressive.
Good. Because this is acting like this. So this is point A, here this is acting, and as it is straight line, so this is AC. Okay, and what about this AG? Is it forming any force equilibrium? इस साइड कुछ लोड है
No, sir.
No, sir.
No, that means what? At this point A, RA is acting and also at the same straight line AC is acting. These two are forming the force equilibrium. But this AG is the only single force, but here there is no force. So this sort of member, the magnitude of this force will be zero, and this sort of force members are called as zero force member. So here AG will be zero.
So for the same reason, the FBH also should also be 0.
FBH. Yes, very good. Very good.
Sir, and the FBF is it's 11 kilonewton compressive.
BF 11 kilonewton compressive. Good.
Sir, F of CG, sir, 12.5 tensile.
FCG 12.5 tensile.
Yes, sir.
Good.
Sir, and F of CD is 7.5 compressive.
Okay. Nice. What about other members? So what is done? FAC done. FCG done. FCD done. FBA. Why you are not trying for this point F? You know BF, right? So two forces, two equilibrium equation.
सर FH में सर 13.65 kilonewton है.
FHF, yes.
Yes, sir, 10. टेंसाइल एंड FEF में 8.25 किलोन्यूटन कंप्रेसिव.
EF बोल रहे हो ना?
यस सर, EF का
कॉम्प्रेसिव और टेंसिल बोला?
कंप्रेसिव.
Good. So EF done, HF done. Then go for point E, it will be easy. As only two member force unknown. What about joint T? DE and EH?
So F of D is 8.25 tensile.
Top DE.
E.
EE, na?
Yes sir, E.
8.25
Tensile.
tensile. Okay. So here EF is, he said 8.25 compressive. So it is like acting like this. There another force is acting like this. Then what will be this DE? This side or this side?
Compressive sir, compressive.
Understood why it will be compressive? Because this is coming compressive. This has to make a force equilibrium with this DE. So this has, because others one is acting in the completely other portion. So these two has to create a force equilibrium. That's why it should be equal and opposite. What will be this EH?
So 0.
EH will be 0. Very good. So this D done and EH 0. Okay, only 3 left.
Sir, I think for the same reason, the FDG should also be 0.
F?
No, 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 sir, no, sir, no, sir, thank you.
Which one you told?
FDG.
FDG, ओके नहीं, क्योंकि इसके
It's
और एक है, यस गुड।
yes.
Be little quick, we have to do another problem.
G, जो
Hmm.
so 0.36 kilonewton compressive.
FDG
Yes, sir.
0.36 kilonewton compressive, okay.
And FDH is 0.45 tensile.
अच्छा, values are wrong, okay. और एक बार
अच्छा,
देख लो, हाँ कुछ कैलकुलेशन मिस्टेक हुआ है। What will be DG?
it's 0.3125 kilonewton.
FDH 0.3. No, why suddenly the values are getting wrong? Other values, it is not possible. No, other values you are doing. Acha, maybe you are doing mistake in forming the angle.
Sir, FDG is, I think it's 9 kilonewton.
FDG 9, but okay, मेरे पास answer 10 है. Let why it is coming like this? What is the angle you are considering here? So this is 3, this is 4.
So it's
So,
90 to 3 by 4.
huh, yes, that part. And this will be 90 degree minus that. So either you can, okay, just don't need to consider this one. Either with cos theta and sin theta. How
Okay,
much
it's
it is coming? Anyone got this FDH 1.25 kilonewton? Is it coming?
So point D नहीं आ रहा, सर करा दो.
Hmm? Okay, but then maybe I don't know. My values are okay. What are my values? I am writing it here. Just let me know whether this is coming or not. If TG I have written as 10 kilonewton compressive, if DH is 1.25 tensile, and if
Sir,
GH,
FDH is 1.25, sir.
huh?
FDH is 1.25
आ
and
रहा है
it's
ना?
10. Yes, sir, it's
Tensile.
10 size.
हाँ, अच्छा अच्छा. Then it's correct. Means my solutions are correct. So 7.5, and it is coming tensile. Anyone got these two, FDG and GH? Okay. Otherwise you can check it out. Okay, because one is coming, other will also come. And please take a snapshot of the whole this part, so that if you are not getting today, you can just check it out. All the answers are written here with along with compressive and tensile. Can I go in the next slide?
Yes, sir.
Okay.
Yes, sir.
Okay. So before that, let me tell you that here we have been introduced to a new kind of properties for this TRAS analysis. That is, for some members will carry zero force, right? And those are called as zero force members. So definitely we can do it from the calculation, but if we want to get before calculation, there is some sort of rules we can find it out. Those rules are, so here we are talking about zero force member. So when we can say that one particular member will have zero force, number one is when there is a joint and that is acted by a single member. When a joint is acted by a single member and subsequent forces, so obviously it will not be able to form the force of equilibrium. Then we have to say that this member is a zero force member. Okay. Secondly, if a joint is connected by two members only, which are not in straight line, so two members which are not in straight line, then they have to be zero force members.
But this should be tensile, na, sir. If one is tensile and one is compressive, then
Yes,
it won't happen.
yes, now that's why the condition is not in straight line. Means it may happen, say this is one joint, this is like this, it will happen, then it will not be a zero force member, no zero force. But if in this case they will not in straight line and only two forces are acting, remember for other cases there are other force members is acting, like this case other force members is also acting, but this case, this is a particular type of scenario which is, I would say, very rare in terms of tasks, but two members are only acting at a particular joint and they are not straight line, then they will be considered as zero force member. If they are in straight line, then they will be equal and opposite and they will have some value. Third, which we have done just now, if there is a joint and this is one member, this is one member, these are straight line, and there is other member. So in this case, say this is P, this is Q and R. So which one will be zero here among this P, Q, R?
R sign.
R, right. So why this is so? Because P and Q, they are in straight line and they are forming the force equilibrium and they will be equal and opposite. Where this R, there is nothing to form equilibrium along with R. क्योंकि P का जो भी तुम बोलोगे cos theta आएगा, sin theta आएगा, that will be just exactly accompany with each other. So R is not having any accompany or it is not having any equilibrium conditions at this particular joint. So R will be considered as zero force member. If you do not can remember these parts, no issues. Try to analyze each joint and you can find out that which part will be 0 and which will be not. But if you want to do it quickly, you can use this process. Okay, so this is very easy. This is little bit, I understand that some questions may arise, but okay. So that's why I told that this is a very rare conditions when only two members are acting at a particular joint. But
I
this
didn't
is, yes, please.
I didn't get yet, sir. The second one.
Okay, the thing is that if there is two forces acting in the straight line, they will be equal and opposite like this.
Yeah, it's of
Okay.
course.
Yes. Now, if these two members which are not acting in the straight line, then how the force equilibrium will be formed?
But if there is one is tensile and one is compressive, then
One is tensile and one is compressive. Okay. Um, yes. Okay. You are asking that way. Then there will be possibilities. I understand. But if those two are in same nature, then
okay, then they both are
huh,
zero.
then it will become 0. Okay, I understand that part. If one is compressive and when one is tensile, then there is possibility that they will not be 0. Okay, that's correct. Correct.
Sir, they both will be zero
Why, sir?
either way.
Why, sir?
Sir, the vertical component will not balance, I guess.
Or one thing I should say that direction will automatically come to the same part because
Yes,
if
sir.
this is, yes, if this is compressive as it said, yes, so if the vertical compression will be like this way, a vertical component, then this one has to act in this way na?
Yes, sir.
So
Okay,
automatically
got.
both will be compressive. Yes, thank you for, yeah, so automatically both will compressive. Okay,
Yes,
so
sir.
and the third case we have done it now. Just then our last problem for today. draw the diagram. It will not be solved today because it will take time. So in the next class, you can come up with the solution.
Yes, sir, definitely.
हाँ हाँ अटेंडेंस ले लेता हूँ एक बार ले लो देन मैं स्क्रीन शेयर बंद कर ऑफ कर दूंगा हो गया
Yes,
Yes,
sir.
sir.
ओके ओके